Welcome. My name is Sean Denning, and I'll be presenting to you about Project Lead the Way, which teaches engineering in the high school level. That's me in the bottom right-hand corner. What is Project Lead the Way? Project Lead the Way is an organization founded between 1997 and 1998 that is devoted to teaching engineering curriculum at the high school level. Project Lead the Way gives the ability for high school students who are interested in pursuing an education in engineering to achieve this by incorporating engineering sciences into a standard high school curriculum. This nationwide accredited program is rapidly growing and allowing the potential for an increase in engineers. You can never have too many engineers in the world. What are some of the benefits of Project Lead the Way? Students get a hands-on experience in the field of engineering and technical sciences. This program was actually incorporated into my own high school, to which I was an active participant in, and I will illustrate some of the projects I had the opportunity to work on. While students are enrolled in this program, he or she may get the opportunity to obtain college credit to be used at a higher education level, especially in the pursuit of engineering. The curriculum that is to be explained later is not secluded from that at the high school level, but rather is incorporated into it. Usually high school students are required to take electives throughout their high school career. When I had attended high school from 2000 to 2004, this program, which was still relatively new, was considered to be an elective program, and the classes that had been taken counted towards those electives rather than college credit. Let's break down some of the curriculum, in which they're broken down into 3 tiers. The first being a foundation in engineering, which students are exposed to a variety of courses that include an introduction to engineering, principles of engineering, and digital electronics. The second tier involves specialization courses, which digs deeper into engineering and involves courses related to aerospace, biotechnical engineering, civil engineering and architecture, and computer integrated manufacturing. The third tier comes with capstone courses, which is the final step into completing the advanced curriculum of this program, which involves engineering design and development, to where the students get a chance to do a research project and present an idea or design to the engineering community. Let's take a closer look. Introduction to Engineering Design. This course involved the first tiers, with engineering design usually involving CAD programs, in which CAD stands for Computer-Aided Design. The programs that are most commonly used are Pro Engineer and Autodesk Inventor, in which the students can create a 3-dimensional parametric models of devices or designs. Below are some of the illustrations of the programs that are used. The next course, known as the Principles of Engineering, takes a different approach to engineering in a political and social manner. The students get an insight into how political and social policies and regulations influence the design of aspects of engineering. This step also teaches a great deal of involvement with ethics involved in engineering. Below is a contrasting set of pictures, the first in the left-hand corner illustrating an electric car from the early 20th century, with the right being an electric car in our current century. Digital electronics gives the students an insight into the basic concept of electrical engineering and basic circuits. Students obtain both the analytical knowledge behind the basic concepts of electrical circuits and back up this knowledge with the development of computer-generated models using a program known as PSpice. On the bottom left-hand corner is an illustration of a PSpice program and an example of a circuit, while the bottom right-hand corner is an actual circuit that I developed while I was in high school in my own digital electronics course. Let's look at Tier 2. Aerospace engineering allows the students to gain knowledge in the spaceflight and the development of aircraft. Biotechnical engineering branches the fields of biology, physics, engineering sciences, and mathematics to aid in the medical field. Illustrated below is what's known as a Da Vinci robot, in which a revolutionary piece of machinery in which common invasive surgery is replaced with this robot, which reduces stress to the body of the patient and eliminates human error caused by the doctor. Civil engineering and architecture prepares the students with its design and knowledge behind structures, bridges, and other concepts behind civil engineering and architecture. Students use such programs as AutoCAD to develop 2D, two-dimensional computer-generated models of homes, structures, buildings, bridges, etc. Below is a design project to which I had the ability to create a bridge that replicated an already existing bridge, this one being of the Tappan Zee Bridge. This model was made out of balsa wood and was to be structurally analyzed and tested to withstand a specific weight. This bridge held 200 pounds before it broke. not bad for made out of wood, and only being about a foot wide. Computer integrated manufacturing gives the students an insight into the concepts behind the manufacturing industry. The student is exposed to all aspects of engineering and manufacturing, including from the design concept to the production line to consumer operation. Students get the chance to use programs that facilitate manufacturing. In my case, we had used computer software to program a milling machine to cut out specific patterns onto a wax block, which is illustrated in the bottom left-hand page. We were also required to develop a system or assembly line to mass produce a series of desktop clocks, which is shown in the bottom right. You can see on the bottom we had even an integrating part to where we engraved onto a nice piece of metal computer integrated manufacturing from 2004, which was my class year. A closer look at Tier 3. This final step in the curriculum involves the students come up with a final design project to which they may seek outside research and present their design to the engineering community. What is involved in this step doesn't only include design, but facilitation of the design, including research, design proposals, work instructions, packaging, prototyping, and further steps required for the industry. Our senior project was to develop a tabletop game and first develop a design proposal, followed by a computer-generated model, a prototype, working instructions, safety instructions, packaging, and then finally marketing. On the bottom left-hand corner can be an illustration of our packaging, to which it was called Mini Pool. On the cover of the page is my beautiful partner that I used to have that helped me design this and actually generate this. And on the right-hand corner is the actual prototype model of our design. Coming to a close. Without this curriculum, students may not be fully prepared when entering into the engineering discipline. Without this engineering curriculum being taught in high schools, students don't have complete exposure into engineering. I know if I had not been exposed to this program, I quite possibly might have never decided on engineering. And without this knowledge that I obtained firsthand in high school, I may have even been lacking the necessary requirements in order to pursue my degree. The only outcome of the program is positive. It only reinforces and helps students to become engineers in the future. Thank you. These are the lists of my resources.